What we're going to learn today, we have already seen it multiple times. We're just going to repackage it and call it function operations. But previously we saw it as like adding, subtracting, multiplying polynomials. Since we're talking about functions, we're just going to do the same thing but make it a function. So I have two functions here. F of x equals 4x plus 2 and g of x equals 4x minus 1. And when I want to add these two together, well, I'm going to write my first function and my second function, and basically just slap a plus sign in between the two, like so. And now I want to combine like terms. So let me look at my x values. I have 4x and 4x, which gives me 8x. And my constant, 2 minus 1 is 1. So 8x plus 1. I'm not going to go in too much detail with adding function operations. You should be able to do this in your sleep. So take two functions and then add in a plus sign, combine like terms. Now subtraction, as we've seen, can be very misleading. It's not as simple as taking two functions like h of x, which is negative 2x squared minus 2, and p of x, which is x squared minus 3x, and putting a subtraction sign in between the two, like so. It's not that simple. Because notice, that may be how the notation looks, h minus p, right? Just have two functions separated by a subtraction. But what did I do to p of x here? I have x squared minus 3x, and I changed the sign of x squared, but I did nothing else to the negative 3x. What this really is saying, this is more of a multiplying than it is a subtraction. And what do you think I am multiplying my function behind the subtraction sign to? I have h minus p, but what do you think I'm multiplying p by? A negative what? 1. So this is more so multiplying than it is subtraction, and it's multiplying by a negative 1. So to do that, I need to put my function p in parentheses here. And I'll need to distribute this negative 1 across. So I get negative 1 times x squared, which gives me a negative x squared, and negative 1 times negative 3x, which turns it into a positive 3x. H, I'm not going to do anything to it. I'm just going to leave it as is. Now you can look at it and combine your like terms. But note, what did I do to p? It started out as x squared minus 3x and became negative x squared plus 3x. What happened to my terms? They switched signs, yes. So subtraction, when you see that negative, you're basically just flipping the signs of the function that that negative is in front of. So flip the signs. I mean, you can also think of it as a addition problem to where before I can add my functions together, I need to flip the signs with the one with the negative in front. In this case, it's p, so my x squared becomes negative x squared, my negative 3x becomes positive 3x. Now I can combine my like terms. So I have a negative 2x squared and a negative x squared, gives me a negative 3x squared. 3x is by itself, so it just stays as a 3x. And likewise, my negative 2 is by itself, so it stays a negative 2. There's my solution with subtraction h by p. Again, flip the signs of the function with that negative in front. So where I subtracted h from p, while I take attendance, I want you to go ahead and subtract p from h. So same functions, but subtract p with h. I want to subtract p from h. So am I changing anything with my function p?
No.
No. So I'm keeping it as x squared minus 3x. Now h, on the other hand, has the subtraction in front of it, so what am I doing to h? Flip the signs. So where I have a negative 2x squared, I have a positive 2x squared. And where I had a negative 2, I now have a positive 2. So again, I'm flipping all the signs. Now I can combine my like terms. So x squared plus 2x squared is 3x squared. I have just a negative 3x and my constant 2. This is what you should have gotten when you subtracted those functions. 3x squared minus 3x plus 2. The other operation we're going to look at today is multiplication. We're not going to look at division. That takes the entire day by itself, and we'll cover that next week. So with multiplication, again, it's something you should be able to do in your sleep. First off, I want to bring up the notation. Please note that we're going to use this dot as multiplication. We're not going to use the x that you probably have seen before, such as f x g of x. Notice how weird that looks to have two x's. So that's probably why they don't use that notation. And we're definitely not going to use something like this, where normally when you have two things next to each other, you imply multiplication. And in terms of operations, that is not multiplication, that is composition, which we're going to talk about tomorrow. So definitely not multiplication there. So when you see this dot, you should be thinking multiplication. And in the case of this problem, I'm multiplying f to g. So my f of x function, which is x, is being multiplied to g, which is x plus 2. And what math term are we going to use here to multiply? Multiplying this x across. That starts with a D.
Distribution.
Distribution, very good. So x times x is x squared. And x times 2 is 2x. So I'm distributing that x to each term inside the parentheses. Just like that. And if you had anything to combine like terms to simplify, then you would do that, like we will in this example. So now I have two functions, h of x and p of x. And I want to multiply h to p. So I have my function h, x minus 2, and I'm multiplying that to the function p, which is x squared plus 7x minus 1. Sometimes when you distribute, when you have two terms on the left and two terms on the right, you use what was called FOIL, first inside, outside, last. Basically what FOIL is saying is every term on this side needs to be multiplied by every term on the other side. So let me look at my first term with h, x. I want to make sure I multiply x to all the terms of p. So x times x squared is x cubed. Again, we are multiplying, we're not adding, so x cubed. X times positive 7x. 7x squared. Hopefully you didn't say 8x, which is addition. X times 7x is 7x squared. And then one more. X times negative 1 is negative x. So that takes care of x. It's been multiplied by everything on the right. Now let's look at negative 2 and multiply that by everything on the right. So negative 2 times x squared, negative 2x squared. Negative 2 times 7x is a negative 14x. And negative 2 times negative 1 is a plus 2. So did y'all follow that? Everything on the left must be multiplied to everything on the right. If I had 3 terms here, I would have to multiply all 3 of those to all 3 of these. I would have 9 total terms down on the bottom. So at this point, we just turn it to an addition problem by combining like terms. So I have an x cubed here, and I don't have another x cubed anywhere else, so I'll just leave that as an x cubed. I have a 7x squared here and a minus 2x squared, so that is a plus 5x squared. I have a negative x. I'm going to add that to a negative 14x. That's a negative 15x. And then I just have this constant 2, plus 2. There we go.